Semiconductor fabrication process in this presentation. And I am Uday Bhole from Scientech Technologies Indore. And I will briefly introduce about my company first, then we will start this semiconductor fabrication process in detail. My company, Scientech Technologies, is located in Indore, Madhya Pradesh, and we are working in this field, in the field of skilling and education from last 40 years. We were established in 1983 and working in different domains like industry, environment, and education. So in education, we are developing the different skilling technology labs like in IoT, artificial intelligence, drones, electric vehicle, quantum technology, and also in semiconductor. So in today's session, our objective is to see the semiconductor fabrication process, just to go through it, how the semiconductor chips are being made. So we will discuss on those topics, and I will try my best to give you the know-how of this technology in a very simple and layman language, so that can be adopted by the students also. And if they are interested, students are interested to study more further on these topics, they can contact us, they can join our internship program, and also they can join to us for on-job training. So let's start with the technology. So I'm just sharing my screen. Yeah. So I hope that all are able to see the screen right now. So this is the semiconductor fabrication technology based seminar, and I'm going to explain you about the fabrication processes. So now, just before starting this presentation, I just ask you to just quickly look around your home or your office or your college, institute, wherever you are sitting right now. Just see what are the things around you. Like in your pocket, there is a mobile phone. In your home, there is a television. In your institute, the computers are there. In our home, again, the washing machine, fridge, mixer, and whatnot. The car, and even the car key is made up of electronics, and all electronics, the base is the semiconductor. Even for buying all these consumer electronics, the cards are required, debit cards and credit cards are required, which are again the semiconductor based, because even the chips are being used inside this debit card and credit card. So what I want to say that in our all this modern life, what we are living right now is all made up of electronics, and because of this only we are able to enjoy the life, and we make our life more easy. So electronics and semiconductor is the base. So semiconductor is very much important in our life. So my presentation will include about the introduction of the semiconductor technology, semiconductor fabrication processes, outsourced semiconductor assembly and testing OSAT, that is the packaging process, and then we will move toward the semiconductor device testing and characterization. And in the last, I will share some of our products which we are using as a scaling solution for training and learning of our hands-on practice for the students. So India imports 90 to 95% of semiconductor chips. Means it is very clear that the huge amount of semiconductor material we are buying from various countries, and the country relies heavily on import to meet its semiconductor demand. Day by day, the development is going on and the new technologies are coming. But if we talk about the AI, machine learning, deep learning, and whatever, if we call the data as a crude oil, then the AI are the refineries. But again, for both the things, the semiconductor is the basic. If semiconductor is not there, we will not be able to enjoy these technologies. We will not be able to make our life more easy. And the annual value of semiconductor chip import is approximately $15 billion, which is in Indian rupees 14.45 lakh crores. So huge amount of import is there, which is very much a big opportunity for us if we see, and that's why government of India is also pushing toward the semiconductor mission and promoting it and for development of its ecosystem, which will not only the semiconductor fabrication, but also the chip designing and also the manufacturing and also the testing and other packaging. So government of India is pushing semiconductor technology in skilling segment also, so that the skilled and skilled manpower will be ready and will be developed, so that that will be absorbed by the industries which are coming in our country. So you see this, the import of our country, the year to year, after 21 to 22, 22, 23, 23, 24, the amount is increasing. So we are totally depends on the various countries for semiconductor. So the chips will come to us, and then we will make some devices and we will assemble it, and we will we can sell our products or we can make our products. So our dependency on semiconductor on various countries is very huge. So that's why it is the requirement of the time, it's the need of the time to develop the infrastructure at our end, to develop the manpower at our end, so that we will be able to solve the our hurdles and can save the money. This is the list. This is the list of the semiconductor export countries like China, Hong Kong, Singapore, Japan, Germany, USA, Malaysia, Vietnam. You can see how much amount of dollar business they are doing, and they are exporting to various countries of the world. So there are various types of technologies, various types of manufacturing industries are there in this field. One industries are only for the fabrication, so they are doing the production like in China or in Taiwan, they are doing huge amount of fabrication. And the countries like USA, they are doing the fabless work. They are doing some fabrication also, but especially if I talk about the countries like USA, the companies like Qualcomm, Apple, they are just doing they are taking the work in the designing sector. So the designing of the chip designing they are doing, and they are after designing they are selling it to the brands and companies. The different companies are buying those designs, and then they are doing the fabrication. So in this way, different kinds of work culture is there, different kinds of industry requirements are there, and ecosystem requires a lot of things in semiconductors. So huge opportunities are there in this business. So these are the five key areas where India Semiconductor Mission 2.0 is focusing. So in India, semiconductor is not a new thing, because we know that in 1983 in Chandigarh, Mohali in Chandigarh, the SCL was started, and we have started the making the semiconductor chips. But that time in 1989, a fire accident took place and the industry was collapsed that time. And our whole semiconductor mission was totally failed that time. But now from 2021, government has taken initiative, and now we are also moving with this 2.0 mission of semiconductor. Our government is pushing towards the development of the semiconductor industries. And till now, the 10 plants are coming into the existence in our country, in which some plants are focusing toward the fabrication and some plants are focusing toward the ATP, which is assembly, testing, and packaging. So the objectives of semiconductor mission is to set up the chip manufacturing plants, that is the fabrication processes, and create the packaging and testing units, which is ATP. As I told you, some of the out of 10 units, I think 5 are working towards only the ATP. Supports the startups in chip designing. Chip designing again a good future, because India has already full of talent for the software designing. So this is the domain where we can work very easily. And even the capex which is required in the above two things is not that much in the chip designing. Some softwares are required, so that can be easily adopted by any industry. Training of young engineers are very much important, as the industries are coming to our country. The skilling requirement is there. So if we will be able to generate the engineers for understanding the knowledge of the semiconductor technology, fabrication technology, so those will be readily adopted by the industries which are coming in our country. So this will make whole infrastructure, whole ecosystem in our country. And also one of the our key focus area to bring the global companies to invest in India. So these companies, our companies, whatever we are working with in our country, they are having the technological tie-ups with some foreign countries, and we are taking the technologies, we are taking the help in R&D. So this kind of work already we have started in Semiconductor Mission 2.0. Now, this is the India's objective of till 2030. The total $110 billion business is expected. What I want to say with this slide is the huge opportunity for the student, for the industrialist, for the every human being. A semiconductor sector is having lot of potential to work on this. So that's why it is the right time to discuss on the chip designing process, understanding the chip designing process. It is a time when that's why we have decided to deep dive into it and understand and the semiconductor fabrication technology. That's why we have Scientech has developed some of the systems for explaining the skilling on or training of students on various technological aspects of the semiconductor technology. So we know that a lot of electronics applications are there in semiconductor. Because of that only we are having the LED lights in our home. Because of that only we are having the air conditioner. Because of that only we are able to get the energy from the solar panels or wind energy. And that's the thing. We can use our home, make it our home or our locking system or our environment smart. Embedded system, medical are the various two applications which are very much required and used and adopted by a lot of products, and these are coming to us. Automotive manufacturing, so many applications are there, and we are totally depend on the semiconductors. And semiconductors, you will be surprised that we are getting this semiconductor chips, all these application by a processing of only a simple sand. So sand is processed and this kind of semiconductor chips are being made. So we will go through that fantastic process, and I believe that this process and this technology is the incredible, mind-blowing process of how we turn the raw material into the macroscopic brains that power the humanity. So it is a very fantastic technology. So let's understand about it in detail. So first, before starting directly to the semiconductor fabrication technology, we will see how and why the semiconductor needs generated, why we need it. So just travel back to 80, 90 years in the period of 1930, 40, when the World War II was taking place, and that time there was the countries like Great Britain, America, and Japan, Germany. They were looking for the radars so that they can track the enemy's aircraft, and they can see it into the night also or without any disturbance. But that time the semiconductor technologies was not there, so they were totally depends on the wall tube. This is the wall tube which was used at that time in World War. So that's the period when this need was generated. So wall tube was used in many electric switches and many electric gadgets that time. So I will explain you what is wall tube, which will make you very easy to understand the semiconductor further slides. So if you see here in wall tube, there is one cathode and one another element, one electrode is anode. So between these two cathode and electrode, two electrodes, there is one grid. So what we do, we control the grid biasing, or we can control the grid polarity. If we make the grid positive, then what will happen? When we hit the cathode, the electrons will be emitted from the cathode, and since the grid is positive, the electrons will attracted very fastly toward the grid and will pass on to the anode, and the current will flow. So this is the one process. Now if we reverse it, if we decrease the voltage of the grid, or if we decrease the or if we change the polarity of the grid to negative, then these electrons will be repelled, then this switch will be off. So it can use as a switch, it can be used as a amplification, it can be used as a semiconductor that time. So this is the process by which we are controlling the current. And in semiconductor also, it is between the conductor and insulator. We are not doing nothing, but we are controlling the current. So grid is the element that time when we were controlling the current. So that's why it was able to use into the electrical and electronic gadgets that time. Now coming to the semiconductor technology, where the transistors are there and they are doing the same work which the wall is doing that time. So to explain the semiconductor, I'm using an analogy for the students especially. Now, if you see, there are three types of water tapes are there. One tape is open, means the water is coming and water is going. There is no bar or there is no resistance into it. Second is there is one wall which is totally closed, so the water is not flowing out of it. So this where there is no resistance, water is coming and going, so it is a conductor. So like our aluminum or any metal, if we give heat or if we transfer any electricity, the current will flow and without any resistance. That is conductor. But we can't do the application of our modern lives like the mobile phone or television. If you want to make, you cannot make with the conductor because there is no control of current. But if you see the insulator, there is no flow of current. So it is also not at all used in our modern day technologies or any electronic gadget because you can't control the current. The current is not flowing. Here current is flowing in huge amount. Here the current is not flowing. So these two are not used for our electronic gadgets. But this third thing is very much important and very much useful. It is a semiconductor. Semiconductor, from its name, it is very clear that it is semi-conduct, which is partially conducting. So that partial conduction is totally based on this wall. We can open the wall, we can close the wall, we can slowly move the wall, and we can control the flow of water. So if we can control the flow of water, a little bit movement of this wall will increase the flow of water. In the similar way, when we are talking about the resistance and flow of electrons, we can control the flow of electrons. So when we are controlling the flow of electrons, it means that we are controlling the flow of current. So when we are able to control the flow of current, we can use it for many of our applications in our life. So this is the semiconductor. This is the beauty of this particular material, which is silicon or germanium. So this kind of material are very useful, and this kind of material we can control the flow of current, and that's why the semiconductor is used in our industry. So coming to the next slide, which tells you about semiconductor and conductor and insulator. From the first slide, now it is very clear that what is conductor and insulator. So the technical reason behind that is, in conductor you can see the valence band and conduction band are overlapped. So I'm not going to the band gap theory and this thing, because I believe that you all are aware about that. But in conductor, since there is no band gap, so the overlapped bands are there, so we can control the flow of current. In insulator, the band gap is very high. It is of the value of +5 electron volt. So there, if you give the electricity to valence band, or if you give any energy, temperature, any form of energy to the valence band electrons of this particular band, the electrons will not flow or will not get that much energy to go and enter into the conduction band, or the material will be damaged. So that's why the semiconductor is a material where the band gap is narrow, and we can control this band gap by use of electronic circuitry, and we can allow the flow of current as per our desire, and we can make the electronic circuitry. This is the technical theory of semiconductor, conductor, and insulator. So like we discussed about wall, the similar to wall, the transistors are there, which is made up of silicon. So we can use it for many applications, like we can use it for switch on, off. Here a transistor is connected. If I can switch on or switch off the transistor, I can pass the power to this lamp and I can use it as a switch. Or I can give a small signal and I can bias it with some power supply, so that amplification also I can do. So I can do the amplification, even the rectification can be done. But amplification doesn't mean that the transistor is generating the energy or it is violating the law of conservation of energy. It is not like that. The small amount of energy we are giving, and with this we are giving a biasing voltage. With that level of biasing voltage, the amplification can be possible, and we can control the level of amplification. And that's the beauty of semiconductors, that's the beauty of this transistor. And that's why the layer by layer transistors were made on the chips, and these chips are becoming smaller and smaller. And that's why our life, the gadgets in our life, what we are using, are also becoming smaller. This is another example where I can give small audio signal with the biasing voltage potential. I can amplify it and I can give it to the speaker. So What I'm telling you, from the 1940s, the vacuum tubes were there to 2022 or 2025 till now, the size of the electronics is becoming smaller and smaller and smaller. So you can see here, when the vacuum tubes were there, this is the era when the computer was made. The name of that computer was ENIAC. It is a big room size computer. When the transistor era came in 1950, that time the smaller things are developed and smaller computers are developed. When we used the ICs in 1960, again the size of the devices are reduced, which is converted to the microprocessor and to the personal computers and to the digital age came in 1990. Now in 2000 we enjoy the age of smart devices, and now we are able to see the use of artificial intelligence, deep learning, machine learning, all we are able to do with the help of the smaller size of the chip, and now the chip size is becoming lower up to the 2 nanometer. So here chip size means I'm not exactly meaning with the chip size. It's not the chip size, it's a transistor size. So size of the transistor is now becoming up to the 2 nanometer, and because of that, thus the various applications we are able to do. Now, if we reduce the further size, the quantum tunneling can take place in quantum technology. This is again one phenomena I'm not going to discuss today right now in this video. We will have another video. We will make another video regarding this quantum technology and the semiconductor devices, in which we can discuss about the quantum tunneling. I just give you a thought on discuss with your teachers or discuss with your faculties regarding a tunnel diode and operation of the tunnel diode. You will understand after this presentation. When you will understand the semiconductor, you will definitely understand the tunnel diode working also. So moving ahead to our next slide. So before going to this slide, I just want to flip the camera and I want to show something. Camera. Camera. So hope you will able to see the camera right now. So I'm going to show you this disc. This is a semiconductor disc. So this disc, hope you are able to see it. So this disc is 4 inch of diameter, 4 inch, and in this disc I can make 1200 transistors. So now the technology about which we are going to discuss, this is so small and so precise, and this is the a silicon dioxide coated disc, which is a P-type disc. So similar to that, N-type disc is also there, and many types of wafers are there. So this disc is called as wafer. So wafer means a semiconductor wafer where the raw silicon semiconductor based chip is created layer by layer, transistor by transistor. We can create the circuitry. I will show you another disc which is having 3500 transistors on one disc. This is one wafer on which 3000 transistors are there. So this, you can imagine, to cut a small transistor from this disk is how much big precise environment is required, and how much precise processes are required. That processes we are going to discuss today. So in this chip, this all the transistors are there which are fabricated after the fabrication process. Now we have to cut one by one transistor, and we have to make one transistor, or we can cut the chip by chip, and we can have a like chip like op-amp or triple pi timer or microprocessor or microcontroller, STM32, whatever the chips we are using, but made up of this kind of wafer, which is diced from it. Diced means cut from this particular big wafer, and then that's the die bonded on some particular die, and then after that we are doing the wire bonding for soldering, and then after that soldering we are able to test it, and after testing we are doing the packaging. So packaging means the last process by which we can get the finished outcome of semiconductor material, semiconductor chips. So now I'm coming back to sharing the presentation. Hope all you will be able to see the presentation slide again. So this is the semiconductor process, which is starting from the wafer manufacturing. Uh, which is starting from the wafer manufacturing, then oxidation, then third process is photolithography, and then etching, and the deposition and ion implantation, and after that metal wiring, electrical die soldering, and sorting, and then packaging. These are the different processes by which a small chip can be manufactured. So let's start about this manufacturing processes of semiconductor and learn about the how the chips are being made in the industries. So wafer is like I told you that thousands of transistors are there on single wafer. So if I tell you on this particular chip, in this small chip, lot of transistors are there. This is the square. Our chip is there. So if you want to cut this chip, one means one chip may contain many of the transistors. So these transistors are fabricated layer after layer, like a building. So whenever we are construction, we are doing construction and buildings are being made. So first we made the foundation. So this wafer is the foundation for this semiconductor chip. And then again we need to make a map also of that building. So that map is the design which is required, what we want to make, how we want to make, what will be the circuitry, and what is the connection. Everything will be designed like in our building map, as we are defining where will be the window, where will be the kitchen, everything we are planning. In the similar way, in semiconductor wafer technology also, we have to plan for its foundation and for its designing architecture, and after that only we can proceed for chip making. So first design is very much important, because whenever we are constructing a building, first the map is required. Similar to that, a design is required for fabrication. So design, for designing, different types of 1D, 2D, 3D tools are available into the market, by which you can make the design of the semiconductor, and you can create a design which is of your desire, or which is used to make for serve your application. Accordingly, we make the design. So for designing, this kind of softwares are being used, like this software, which is a very basic fundamental software by which students can learn how we are making a transistor on the chip. So the designing we can explain, we can teach. Here the green box you can see, the green box is the N well, means this the green box is the N type of semiconductor, and the purple center, this purple is the P type diffusion, means we are doping the P type in this particular region by the method of photolithography and many films. The blue lines are the metal layers. The blue lines are taken for the metal layers, and these other little square boxes for the contacts. These square boxes are taken for the contacts for the next layer of the transistors. So this is the fundamental design I am showing you. This kind of design softwares are there by which you can make NMOS, CMOS, and designing transistors and even ICs and VLSI chips, FPGA chips. You can design with the help of this kind of softwares. These are some cross-sectional views. I'm not going detail in designing software. I'm just giving you idea that how the semiconductor processes are there, and the designing of the chip is the first process. By the use of software, you are doing designing of the architecture which you want to make. Once the architecture is ready on that software itself, you can even test it. So whatever you have designed, the software will tell you the parameters or result analysis which will be achieved during the testing. So this testing also you can do on the software itself before going for the fabrication. If your test analysis is passed, if these are okay, then only the design is going to be implemented or photocopied or constructed on your wafer. So after designing, we have to start the making. We need to understand the making of the semiconductor wafer process, semiconductor fabrication process, in which first is the silicon extraction from sand. So first the silicon, as it is abundantly available into our planet and it is low cost. So we are using silicon, and silicon particles are taken since it is abundantly available. That's why we are using silicon. It is of low cost. It possesses the semiconductor properties which are very much excellent, and it provides high reliability and stability also. So it is a well established technology in which we are using the silicon. And again, one more reason for using silicon is the silicon atomic number is 14. So you know that it's from periodic table, its atomic number is 14. So its configuration will be 2, 8, and 4. So in its valence band, only the 4 electrons will be there. But if it's a intrinsic nature, or if it's in purest form, all the semiconductor atoms will make a bond with the nearest semiconductor atom and will be binded in to form a crystal. So you can't use it for the semiconductor because there is no flow of electron until there is some heat or some energy is given. Then only a small amount of electron or hole can be generated. So in intrinsic or pure form, the semiconductor silicon is not used. That's why we are doing doping, and that's why we are making the semiconductor extrinsic. And so why silicon? Because we can make it extrinsic. In extrinsic, the silicon atomic number is like 14, so 2, 8, and 4. So in outer orbit of the silicon, you can see the 4 atoms are there. So 1, 2, 3, 4 atoms of 4 atom of silicon are can bind with the arsenic's 5 atoms, 5 electrons. So this green are the electrons in arsenic. The in outer orbit, this is the circle of arsenic, where 1, 2, 3, 4, and fifth electron is free. So this can move. By giving a small energy, this can move. So since the electron is moving, that's why electron is negatively charged. That's why this material is called as N-type. Similarly, if we see in the boron, in boron, there are the 1, 2, 3 electrons are there in its outer orbit because its atomic number is 5. So but a hole is created in the outer orbit. In first orbit 2, and outer orbit only 3 electrons. So one hole is created because there is one vacancy. So this electron can easily adopt this hole and can make this charge as a positive. That's why this kind of semiconductor is called as positively charged semiconductor. And so a wafer I shown you is p-type or n-type is being made by this kind of material doping, maybe a arsenic, maybe a phosphorus, maybe a boron. So this kind of doping we are doing to get our application. Coming to the fabrication process again, here I tell you why we are using semiconductor. But when we were here, the semiconductor is extracted from the sand, the silicon material is extracted from the sand, then silicon is heated, sand is heated up to a particular high temperature where it melts, and high purity liquid is we are getting, and we are getting in the form of a cylinder. From this cylinder, you can solidify it, means you can just after cooling, the crystallization happens and it's solidified. So this solidified rod can be cut into the wafers or chips. So this kind of wafers are cut and we can get the wafer like I shown you. So this is the one wafer which we can cut from this ingot. This silicon crystallization rod is called as ingot. From this ingot, the chips are being made. The chips are sliced, and this wafer is also sometimes rough and contain defects. So we need to polish it. So there are polishing machines are used to polish the surface so that our surface of the semiconductor material will be plain, will be smooth, so that we can do the further processes of say transistor growing of the transistor. Yes, this wafer word is coming from the biscuits. It's like the same way we are doing the wafers, taking the wafers from the silicon ingot. So this is the main material of the semiconductor. So we are calling it as a foundation of any semiconductor chip, which is extracted from this sand. So the greater the number of the chips can be generated, that is totally depends on the diameter of the chips, and that's why the diameter is reached up to 300 nanometer. It's a big wafer, 300 mm, 300 millimeter is the maximum disk right now which we can achieve, and many of the chips can be taken out from the single wafer. But still, this chip is not conductive. So we need to make it conductive. We need some doping process and some deposition, ion implementation. Lot of processes are required. So resultant disk is not conductive. So we'll move ahead. And so the process which makes this semiconductor wafer conductive is required. So first, before this, we need to go to the oxidation process in the second step. So it is very much required because there is external environment effects can be happen onto the wafer, and when we are growing or when we are designing a transistor, that way directly affects our semiconductor transistor. So to avoid that, we are using this process of oxidation, and during this process we are depositing the film of oxygen and water vapor on the surface of any semiconductor material, and this processes and also blocks this process also blocks the current leakage between the circuit, because it is a kind of insulating layer. So this process blocks the leakage current also, and also it protects from the external environment. So oxidation process is just for protection of the chip or protection of the our disk wafer which we have generated as a foundation. Coming to the next process, photolithography. So photolithography is like, just from its name, it is very much clear that we are doing we have seen the analog cameras in earlier days. There were films which is processed and developed. Similar to that, this photolithography process is there, where you can draw your blueprint to make the circuitry, to draw circuitry on your wafer. So since it is similar to the photo development process, it is called as photolithography. And in photolithography, what we are doing exactly, we are using the mask. So this kind of mask, if it is your circuitry, this film is your circuitry and this is your wafer, then what we can do based on the circuitry, you can develop a film which will be a negative or positive. That will be depend on your photoresist material. Photoresist material is also available in positive and negative, both the type. So it will allow the flow of light from the transparent side, and it will stop the light from the flow of this dark place of your film. So wherever the light is coming, the photoresistant material may be weakened or may be strength. That depends on your positive or negative material of the photoresist material. So that is totally depends on the type of material. So once you make this kind of mask, you can use this photoresist material or you can apply this photoresist material on the wafer. So this is wafer, this is oxide film which we made in the first particular process, and this violet color is the film or the layer which we applied with the help of photoresist material. So this is the photoresist material, this is the oxide material, this is the semiconductor silicon material on which we draw these three layers. Now this mask will allow the flow of light from the transparent size. So here the light is coming, here light is not coming because mask is there. Here the light is coming, here the light is not coming. In the similar way, based on our circuit requirement, we are process this mask or we develop this mask. And once this mask is ready, our circuitry will be created on the wafer, and we can now develop it with the help of fluid, and we can remove the unwanted photoresistive material which is there on the particular wafer. Then we will move towards the etching process. Once the etching process is done, we can remove the unwanted oxide coating also. So that will remove the unwanted material of all the unwanted material of the disc, and your exact what the circuitry you need will be in front of you. The unwanted material is removed, you can see. Etching we can do in the wet type also with the help of wet etching process, where we are using the liquid. In dry etching process, we are using the gas. Sometimes it is also called as the plasma etching. So this kind of etching, we can remove the unwanted material. Now you can see this is the wafer, this is the oxide film, and this is the photoresistive material. But your circuit is developed here. What you are doing now, still it is not conductive. Now to make it conductive, we have to dope it, or we have to do the ion implantation here. So deposition and ion implantation process comes into the picture after this step. Now we are working in a very precise technological domain. So because the size of the chip is the smaller than your fingernail, or it's a thin like a sheet of paper, less than a sheet of paper. So it should be very precise processes are required. So this kind of photolithography and etching we have to do layer after layer, transistor after transistor, layer after layer. Every time you have to do this types of process. Repeatedly processes are required in semiconductor industries. So, and every time after one layer, if you are going for the second transistor layer, third transistor layer, you have to give you have to provide an insulation layer also, so that the conduction will not happen between first layer and second layer, and then you can make your circuitry on the top layer. So insulation layer is always one after one. So this kind of insulation layer when we are doing, so we are protecting the stack circuits. So it is called as the thin film. So these thin films are formed on layer after layer, and then this thin film deposit is done by using the method called as vapor deposition. So it is as good as like the oxidation process we saw in earlier, where we did it for the process of making it rugged or making it free from the environment, or making it non-conductive from the other circuitry where we don't want. So this kind of process is called as thin film deposition, which is achieved by the vapor deposition. So here again, this is wafer, this red color is your oxide film, and this is your thin film which you doped here, which you deposited. After deposition of the thin films, or sometimes before, we need to do ion implantation, because it is dependent on what we are doing based on the application. These two processes can be altered. So ion implantation is the process where we are doing the doping and making the wafer conductive. So when we are doing the doping, that doping allow the flow of electrons. So that's why the extra impurities we are making. So that impurities also in the form of film. So that film deposition is done by the laser, and the laser plasma laser beam is used, and because of that the uniform layer is formed on the silicon material. So now the impurity addition in silicon, as we have seen in the earlier slide also, if it's a boron, then it's a P type of material, one hole is there, so this impurity is added. In N type, the phosphorus or any this kind of impurity is added where the electron is extra. So this kind of impurity is added where the flow of electron can be easily possible by giving a small amount of temperature or by giving a small amount of electricity, and we can make our application as we desire. So this ion implantation process is making the film conductive, or we can use it, or we can also call is doping process. And after ion implantation and thin film deposition, these two processes are completed, we go or we move toward the metal wiring process. In metal wiring process, a metal wire is of aluminum, tungsten, and titanium. This kind of material is used for metal wiring processes. These processes are also a deposition of thin film only. It's also deposition of thin film only, which is the material is like aluminum, titanium, tungsten, from where you can take the contacts. Because our circuit is ready, our doping is ready, now we want to take the contacts. Suppose if you are designing a diode, a PN junction is there, you dope the P junction, you dope the N junction, but now you need to take the contacts from this PN junction. So for that deposition of aluminum material or titanium material or tungsten, whatever is required, that we have to do. So that process is called at metal wiring, from where we can take the contacts. So the process of depositing a thin film, metal film, to allow the electricity to flow through it, this is called as the metal wiring. And then lastly, the EDS process comes into the picture. It is the electric dye sorting, means whatever dye you created, as I shown you a disk in the presentation in the video, that a disk is containing 3000 transistors. So if you want to see the 3000 transistors, out of these 3000 transistors which you created, which you developed, how many transistors are working, what is the yield of your design, so that is to be done by electrical testing. So in other words, it is a testing step to sort out the defective chips. So how we calculate this yield? So it is number of working chips on a wafer divided by maximum number of designed chips. Suppose if on a wafer, if 100 number of chips are there and 10 numbers of chips are not working, so it is called as 90% yield, because 10% is not working. But if 70% is not working, so yield is very poor. So whatever you manufactured is of very poor quality. The lot of chips will become defective and lot of losses will be there. So that's why this EDS process is very much important. Before going into the packaging, this chip testing is very much important. So on the wafer itself, we are doing this testing and make clear that yes, these chips are working. If these chips are working, those chips were diced or cut, and those chips are going for the packaging. So now we are coming to the packaging process at last. So in packaging process, so the suitable chips, whatever we have seen EDS, whatever the correct chips are there, are cut into the individual semiconductor chips, and the small chips are cut, which are going to be bonded into the dies. So that you can take the contacts, like in your IC socket, their contacts are there. So you can do wire bonding from this metal contacts, and you can take your this device in your circuitry. For making it to use in your circuitry, we have to cut from the semiconductor wafer, then we have to dice it. Then after dicing, we have to die bond it, means we have to stick this chip into this particular die, and after that we need to do the wire bonding. So this is required. So wafer cutting, then chip bonding, where we are putting this chip into this particular die, and once the die is bonded here, we can take the wire bonding. We can do the wire bonding from where the metal contacts were there on the chips. So we have taken the wire from there and soldered on our IC socket terminals. So it will be used for testing or used for the application. So after this, on this again it is a raw form, so we have to mold it, we have to put some resin or some material on it, so that it will be completely comes into the solid form, and it will not be affected from the external environment or our hand electrostatics, because still in electrostatics is very much important after this also, but that amount of at least we protected from this material what we are coated here, so we have protected the chips. So after this, we are going for the marking, like we can do any mark or brand, whomsoever design, they can make their branding here. And after marking a branding, it is going for the final testing. And this final testing, if the chips are okay, it goes for the market. It goes into the market. Is the last process of the chip manufacturing. So from this semiconductor transistor layer to layer deposition, a single chip die creating, dicing, and then bonding, and then the packaged semiconductor device is ready. So this is the beautiful journey of getting a semiconductor device from the raw sand, which we saw today with the help of this presentation. And in this presentation, I tried to explain the basic process of manufacturing of semiconductor chips. But for this hands-on practice on these processes, we have some solutions. Scientech is having some solutions. I'm just briefly giving you an idea on those testing training systems also. Like here, this is the testing of transistor and diodes, where you can make transistor by the diodes. So you can test the basic fundamentals of transistor. Or you can make a IC op-amp by with the help of different multiple transistors. So you will get idea how many transistors are there in one op-amp and how they are working if you are making by transistor, and how it is a complex and process of making 16 transistor in one op-amp or 15 transistor in one op-amp. So that kind of idea we can give from this product. This product is like for understanding the different kinds of packages, different kinds of semiconductor devices and their packaging. This is the designing workbench, where we are able to give the idea on designing of the semiconductor fabrication. Before fabrication, designing is required. So that designing tool is given here. Students can design, they can make the practice of making a diode, making a transistor, which will give a basic idea of understanding of designing of semiconductor devices. Then the properties, electrical, optical properties, magnetic properties, thermal properties, lot of properties of there in the semiconductor. So to teach them, different kind of training systems are there. So like this is the material testing workbench, where we give the idea about the what is the material, how it is behaving, and when you put it in the magnetic field or when you heat it, what happens to a semiconductor. So this kind of knowledge of material properties we are giving with the help of these products. And lastly, we have the OSAT lab, in which the outsourced semiconductor assembling and testing, we are giving the clean room facility training system, because clean rooms are very costly, but we have developed in this way that at the low cost, student can learn about the whole OSAT lab, and they can do some dicing, they can do some wire bonding and die bonding, and they can create their own some diode or transistor. And at basic level, they understand what is the process of dicing, die bonding, and wire bonding. So this is all about the this is all about the semiconductor process of fabrication, its material property, and what is the journey of semiconductor material, why and how this is generated, this journey has created, what is the need of the semiconductor. I try to include all these topics in this session. If you have any query or if you have any question, we can discuss, or you can write to me on this email ID, or you can contact me directly on this my mobile number, which is 98932 or you can write it udayuday@scintech.bz. With your queries or your question, I will be here. I will be happy to answer you. Thank you very much. Yeah, if any question is there, we can talk right now.
No, sir. Thank you.
Thank you very much, ma'am. Thank you to all of you for listening to me. Thank you very much.